Scientific notation. Scientific notation is an alternative way to write numbers that have a lot of zeros in them at the beginning or at the end. The form for a number to begin scientific notation has a number times 10 to a power. Sometimes that power is positive, sometimes that power is negative. The number could also be positive or negative, but the number will always have only one digit in front of the decimal point. You may see a digit or two afterwards, or even more than that, but you will always only have one digit in front of the decimal point. So let's look at some numbers and write them in scientific notation. Here are numbers that are very close to 0 because they have the decimal point, then a lot of zeros in here. We want to find what we call the non-zero part, the digits that are not 0. The decimal point will go after the first one. So for 243, our decimal point will have to go after the 2, 2.43. Then that's going to be times 10 to some power. The power indicates how many times that decimal place moved. Okay, in this case, in order to make this number equivalent to this number, we need to divide 2.43 by 10 to a power. So that's going to make that a negative exponent. So this is going to be how many places? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in scientific notation, this number is 2.43 times 10 to the negative 10th power. And the second problem is going to work the same way. We go to the non-zero part. And you may say, but that's got a 0 in it. It does have a 0 in it, but it's between non-zero digits. So 3.02 is going to be the number at the beginning of our scientific notation, times 10 to some power. So in this case, we want to see how many times the decimal point moves. 1, 2, 3, 4, 5, 6, 7. So this will be times 10 to the negative 7th power. One more thing we have to take care of here. Because the number itself is negative, that's going to make our 3.02 negative also. So to put this in scientific notation, it becomes negative 3.02 times 10 to the negative 7th power. Now here's some numbers that are a long way from 0, meaning the zeros are at the end. So let's take a look at the non-zero part. Here again, there's an included 0 in there. So the decimal point is going to go between the 3 and the 0. 3.045 times 10 to a power. Now this time, in order to make this number equivalent to what we started with, we have to multiply that 3.045 times 10 to a power. So this time my power is going to be positive. So see, every place the decimal point moves was one multiple of 10. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm sorry, I said a multiple of 10. I meant a power of 10. So in scientific notation, this is 3.045 times 10 raised to the 10th power. 15 billion, you don't see the zeros, but remember what 15 billion is. If you put all those zeros there, this would be how 15 billion would look. So the non-zero part of this would be 1.5. Then the number of places the decimal point moves would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I happen to be using 10 a lot, don't I? Now, let's go the other way. Start it in scientific notation and end up writing it as a regular number. 9.13 means we're going to take 9.13 and multiply by 10 to the 5th power. Every time you multiply by 10, moves the decimal point one place to the right. So there's 1, 2, 3, 4, 5 times. So this is going to be 913,000. Our next number has a negative exponent, so that means the decimal point is going to move the other way. So we have 1.409, and here we want to move the decimal point 6 places to the left. 1, 2, 3, 4, 5, 6. So we'll have a 0 in each of these to hold the place. So this ends up being 0.00001409. This number, 4, doesn't have a decimal point in it. Well, or does it? 4 is really 4.0, isn't it? So if I take 4.0 and multiply it by 10 to the 2nd power, that means I'm going to have to move my decimal point 2 places to the right. So I get 400. But because of this negative out here, that makes my number a negative 400. And finally, 3.5 times 10 to the 0 power. Do you remember what your exponent rule said about anything to the 0 power? Anytime you raise a number to the 0 power, you get 1. So 3.5 times 10 to the 0 power is the same as having 3.5 times 1. And anything times 1 is just going to be itself. So there, our answer is 3.5.